Really taking the next derivative. That's how you do this. This is the tricky part, implicit differentiation. I'm only going to show you one example on this because it kind of repeats itself over and over again, how you do the derivative with implicit differentiation, second derivative, I should say. So just really pay attention to how we do this. All right, so in order to find the second derivative, we first have to find the first derivative. So derivative of sine is going to be cosine y, and then times the derivative of the inside gives us dy dx. So remember, if you're ever taking the derivative of y, you also have to include a dy dx. Okay, and then equals the derivative of x is 1, plus the derivative of y is 1, and then times dy dx. All right, let's get the dy dx is on the same side, so cosine y dy dx minus dy dx. Let's make sure that's clearly a minus sign, equals 1. Factor out a dy dx. So remember this from a few lessons ago, I hope. Cosine y minus 1 equals 1. And then I finally have that the dy dx is going to equal 1 over cosine y minus 1. Okay, so now we'll take the second derivative. So I'm going to come back up here and start over again. I'm going to say that the second derivative, so d squared y over dx squared, is going to equal the derivative of this. I want you to rewrite this as cosine y minus 1 raised to the negative 1. That makes this a little easier. If you can think of this as this is all raised to the negative 1, then you can just see it's going to be the chain rule. Okay, so let's apply the chain rule here. This is negative 1 comes down to the front, and then it's going to be cosine y minus 1, and now it's raised to the negative 2 times the derivative of the inside. Now we got to go to the inside and take the derivative of that. So the derivative of that is going to be negative sine y, derivative of negative 1 is just 0, times the derivative of, we did the derivative of cosine y, now you have to do the derivative of y, which is dy dx. Okay, this is where it becomes a little bit more complicated. In fact, I'm going to do this. D squared y. Let's clean this up just a little bit before we do our next step. So the negative and the negative, those just cancel. And so I'm going to have a sine y on top of a fraction. On the bottom I have cosine y minus 1 quantity squared. And then I have times dy dx. So now it is literally, this is how all of these problems work for implicit differentiation. You always end up with a dy dx here in your second derivative. And when that happens, what do you do with it? That's where you do substitution. We know what dy dx equals. It equals this. So that dy dx goes over here to that dy dx. So we are literally just substituting in this whole thing right there. So this becomes sine y over cosine y minus 1 quantity squared times, and then it's dy dx, we substitute in what it equals, which is just 1 over cosine y minus 1. That's dy dx, and then you're done. Simplify. Sine y over, and then we have a cosine y minus 1 quantity cubed now, since there's 3 of them. And so that is the second derivative with implicit differentiation. Oh, I forgot the little squared right there. Sorry, squared. Dx squared. So that's the second derivative, implicit differentiation. It's all about substitution. Once you get a dy dx, you have to go back to the previous step of what was dy dx. Now in this packet, in this lesson, there'll be a couple other little things that get thrown out at you that make you think about derivatives and second derivatives and all that. But this is the gist of what you have to work with. So rock that mastery check and the test. This is the last lesson for Unit 3, and I'll see you back on our next unit.